Hello everyone. Today we'll be doing the second mini lesson. This is on Earth's mantle. Earth's mantle is the second interior layer of the Earth, represented by these flowing motions. We will talk about that. So in the mantle, it is divided into two layers. The upper mantle, which has a depth of 660 kilometers, the transition zone, which is between the upper mantle and lower mantle, and then obviously the lower mantle, which has a depth up to 2,900 kilometers. So that's very deep. So we're getting even closer to the third layer of the Earth. So, an important thing about the mantle is that it includes the asthenosphere. Today, we're going to be talking about the second part of the Earth, called Earth's mantle. Here, you can see that we're going to be talking about this red part. This was the crust, the part that we can see, and now we're going to be talking about a more internal layer. So, Earth's mantle surrounds the core, and it can be divided into two layers. The upper mantle, which can be right here. Then there's a transition zone, which is between the upper mantle and the second layer, known as the lower mantle. So before we go on, I just want to bring to your attention that in the last video, we talked about how the lithosphere, the seismic plates, move on the lithosphere. So as you can see, the crust is right here. Then below that, which makes up the crust and the upper mantle, is the lithosphere. And here, the lithosphere is solid, rigid, but brittle, so it can easily break, which is why the continents can move on them. Just to point out, this is a subduction-like flow. We will be talking about that in class. But the layer under it is called the asthenosphere. And this is a solid upper mantle, but it is so hot that rocks can flow. They don't flow like ocean or water, but they kind of creep around and they can morph and change shape. So the lithosphere is above the asthenosphere. So, as I was saying, in the asthenosphere, it's solid, but it can flow. So that's just saying how rocks can change without breaking because they are soft and ductile and can change shape. So when I think of mantle, I think of motion because the temperature is so hot and it's solid, but it's flowing and you can feel seismic waves and motion. So I just think mantle, motion. So looking at a lava lamp, you can see that blobs move around at different rates. Some of them stay on the bottom, some stay to the top, some just float around. So the reason for that is density. So that the definition of convection is the process by which less dense material rises and more dense material sink. So if we were to go back to the lava lamp, less dense material rises, so these are less dense, so they're going to go up, but then more dense materials sink at the bottom. This fluid-like motion occurs about 7 centimeters per year. Thinking on an Earth scale, that's very large. Convection is temperature-driven since rocks expand, so that's very important. I will put a question about that. Convection is temperature-driven. And a little slogan to help you is hot rock rises and cool rocks sink. So now I just want you to do a very short creative activity. I want you to write a paragraph and pretend that you are the mantle of the earth. How would you feel? How would you associate yourself with? Or what type of emotions would you have? Now, this is going to be a very short activity in the morning just to see if you understand what the mantle is and what I need to expand upon. And you can write it in the form of a poem, a song, and if you would like to, you can perform it. So just make sure that you do the homework questions, and that will be right below this video before you come to class. And that is how I will take attendance, is for who sent the forms in.